Scope of physics and excitement. Physics is a very vast subject. The scope of physics deals with the magnitude of physical quantities like energy, mass, etc. The scope of physics is best understood under the three disciplines microscopic, mesoscopic and macroscopic phenomena. Number 1. Microscopic. Micro means small. The microscopic study in physics is very useful because its range is to atomic, subatomic and nuclear physics. Atom and nuclear energy is very necessary in this modern world. Day to day our population increasing, and we need a large amount of energy, and this energy in basic study is provided by physics in the form of atomic. So physics deals with the subatomic particles, e.g. electrons, protons and neutrons. Atomic physics is the field of physics that studies atoms as an isolated system of electrons and atomic nucleus. Atomic physics typically refers to the study of atomic structure and the interaction and the processes by which these arrangements change. This comprises ions, neutral atoms and, unless otherwise stated, it can be assumed that the term atom includes ions. The term atomic physics can be associated with nuclear-powered and nuclear weapons, due to the synonymous. Physicists distinguish between atomic physics, which deals with the atom as a system consisting of a nucleus and electrons, and nuclear physics, which nuclear reaction and special properties of atomic nuclei. As with many scientific fields, strict delineation can be highly contrived, and atomic physics is often considered in the wider context of atomic, molecular and nuclear physics. Number 2. Mesoscopic. Mesoscopic physics is a subdiscipline of condensed matter physics that deals with materials of an intermediate size. These materials range in size between the nanoscale for a quantity of atoms, such as molecules, and of materials measuring micrometers. The lower limit can also be defined as being the size of individual atoms. At the micrometer level are bulk materials. Both mesoscopic and objects contain many atoms. Whereas average properties derived from constituent materials describe macroscopic objects, as they usually obey the laws of classical mechanics. A mesoscopic object, by contrast, is affected by thermal fluctuations around the average, and its electronic behavior may require modeling at the level of quantum mechanics. When scaled down to a meso size, starts revealing quantum mechanical properties. For example, at the macroscopic level, the conductance of a wire increases continuously with its diameter. However, at the mesoscopic level, the wire's conductance is quantized. The increases occur in discrete, or individual, whole steps. During research, mesoscopic devices are constructed, measured and observed experimentally and theoretically in order to advance understanding of the physics insulators, semiconductors, metals and superconductors. The applied science of mesoscopic physics deals with the potential of building nanodevices. Mesoscopic physics also addresses fundamental practical problems which occur when a macroscopic object is miniaturized, as with the miniaturization of transistors, semiconductors, electronics. The mechanical, chemical, and electronic properties of materials change as their size approaches the nanoscale, where the percentage of atoms at the surface of the material becomes significant. For bulk materials larger than 1 micrometer, the percentage of atoms at the surface is insignificant in relation to the number of atoms in the entire material. The subdiscipline has dealt primarily with artificial structures of metal or semiconducting material which have been fabricated by the techniques employed for producing microelectronics circuits. There is no rigid definition for mesoscopic physics, but the systems studied are normally in the range of 100 nanometers, the size of a typical, to 1000 nanometers, the size of a typical bacterium. 100 nanometers is the approximate upper limit for a nanoparticle. Thus, mesoscopic physics has a close connection to the fields of nanofabrication and nanotechnology. Devices used in nanotechnology are examples of mesoscopic systems. 3 categories of new electronic phenomena in such systems are interference effects, quantum confinement effects and charging effects. Number 3. Macroscopic. Macroscopic, large enough to be visible to the naked eye. Compare microscopic. Comprehensive, concerned with large units. Physics capable of being described by the statistical properties of a large number of parts. Also called megascopic. Physics deals with heavenly bodies such as galaxies, stars, moon, sun. The structure, mass and motion of these bodies also deals with solar system and Earth and atmosphere and its pressure. The solar system is the gravitationally bound system of the sun and the objects that orbit it. It formed 4.6 billions of years ago. Rom the gravitational collapse, a giant interstellar molecular. The vast majority, 99.86%, of the system's mass is in the sun. with most of the remaining mass contained in the planet Jupiter. The four inner system planet Mercury, Venus, Earth and Mars are terrestrial planets, being composed primarily. The outer system are substantially larger and more massive than the terrestrials. The two largest, Jupiter and Saturn, are gas giants, being composed mainly of hydrogen and helium. The next two, Uranus and Neptune, are ice giants, being composed mostly of volatile substances with relatively high melting points compared with hydrogen and helium, such as water, ammonia, and methane. All 8 planets have nearly circular orbits that lie near the plane of Earth's orbit, called the ecliptic. Excitement means curiosity to know how it happened or what happens. The ancient people. The ancient people or the older generations may not know the advanced technologies like treadmills, GPS technology, teleportation, etc. Still, those people tried to know and understand the subject to gain in-depth knowledge. Then they think of the utilization of this knowledge. This leads to the inventions of several enhancements. This curiosity of learning physics is nothing but the excitement of physics. Conclusion. Hence the scope and excitement of physics can be understood in a clear idea. However, the scope of physics can't be restricted here. The scope of physics keeps on changing and expanding its range according to the changes in day-to-day life.